Hi guys, this is Maysie from Maysie's Algebra Initiative, and today I'm going over Unit 2 in the Algebra 1 curriculum. The overview for Unit 2 is basically we have two-step equations, absolute value equations, and inequalities. So let's get started. Okay, first off we're going to start with two-step equations. The first step in a two-step equation is to combine like terms. Like terms are just they're terms with the same number of variables. So 4 and 20 would be like terms because they have no x's. While if I had 2x and 3x, they'd be like terms. 2x squared and 3x squared would be like terms, and so on and so forth. So combined like terms. And when we do these type of equations, we first identify our like terms. We have 4 and 20, and to get them on the same side, you have to do the opposite. Since there's a positive here, we're going to subtract 4 to cancel it out from this side, and what we do to one side of the equal sign, we must do to the other. And if it makes you feel more comfortable, you can always draw a line down the equal sign to make sure that you're doing the same thing to both sides. So 20 minus 4 is 16 is equal to 2x, because that's what's left on this side. Our second step is to just solve for x, get it on its own. And because 2x, that's multiplying 2 and x, we do the opposite, so divide 2 to both sides of the equation. 16 divided by 2 is 8, so our answer is x equals 8. But there's a third step I want to involve, and this is your check step. Checking just make sure you do your work correctly, and you do this by plugging into the original equation. So 2, we plug in the 8, plus 4 is equal to 20. So 2 times 8 is 16, plus 4 is equal to 20. 20 is equal to 20, and you put a check mark or a smiley face or a heart, whatever makes you remember to do your check step. This will solve any simple errors that may have occurred in the problem. Alright, let's go into our next example. We're going to do the same 3 steps. Step 1 is like terms. So we're going to 10 and 5 are like terms. Since it's a negative this time, we're going to add. We must do to both one side of the equal sign, we must do the other, so plus 10. So 15 is equal to 3x. These cancel. Now we isolate x and solve for it. Same thing as solving for x. So divide by 3. It's the opposite. Divide by 3. Do it to both sides. X is equal to 5. And now we're going to check. So we got 3. Plug in the 5 where the x is in the original equation. Minus 10 is equal to 5. 3 times 5 is 15. Minus 10 is equal to 5. 5 is equal to 5. Check. Awesome. A third example. Do the same 3 steps. So step 1 would be combine like terms to both sides. Do the opposite. Since it's a positive 5, whatever sign's in front of it indicates it. So positive 5, we subtract. They cancel, and we do it to this side, so 30 is equal to 5x. Now, we do our second step, which is the x step. Get x on its own. So, because this is multiplying by 5x, you do the opposite, divide by 5 both sides. X is equal to 6. And then we check. See, it's an easy 1, 2, 3 step. Just remember your 1, 2, 3. So we got 5, plug in the 6 where it belongs. We're good. Okay, so here's our practice problems page. If you want to work these out on your own and check your steps, which I highly recommend you do, just pause the video now and then unpause it for the answers. Okay, So here are my answers, and I left out the check step on these for the sake of space, but you should always do the check step because it's very important in catching simple errors that are commonly made by just passively doing these types of problems. So the first one, after I added 14, then divided by 4, I got x equals 4. Then I subtracted 12 to combine my terms, and divided by 6 to isolate x, and I got 2. And I did subtracted 5, and then divided by 3, ended up getting x equals 3. Okay. Okay, now we have absolute value. So our first step in the absolute value equation is to get the absolute value on its own. Isolate the absolute value. And what an absolute value is, you see these lines here and here. It's whatever's inside that. That is the absolute value. So let's get this on its own. And so it's 3 times the absolute value, so I'm going to divide by 3 to both sides. So I'll cancel out that 3, and I will be left with x plus 2, and the absolute value is equal to 1. Now, my next step, step 2, is to write two equations. And EQTN is an abbreviation for equation. Write two equations. One with a positive value and one with a negative value. What I mean by that is that we're going to make this term positive and negative. So I'm going to write two equations. They're going to stem off this. So, and you're going to take away the absolute value. So x plus 2 is equal to 1, and then x plus 2 is equal to negative 1. See how one is positive and one is negative? Now, we're just going to solve, and then step 3 is just to solve, just solve for x, like any normal two-step or one-step equation. So, we're going to subtract 2, because that gets rid of that. X is equal to negative 1. And x is equal to negative 3. Step 4 is to check. You do this by plugging each one back into the original equation. So 3, negative 1 plus 2 is equal to 3. And then 3, the absolute value of negative 3 plus 2 is equal to 3. So the negative 1 plus 2 is positive 1. 3 times 1 is 3. That's good. And over here, it's going to be 3 times negative 1, because negative 3 plus 2 is negative 1. The absolute value of negative 1 is 1, so 3 will equal 3. Awesome. Now, here's our next example. We have 1 plus, let me make that look more like a 1. It kind of looks confusing. That's a 1 plus the absolute value of x plus 7 is equal to 9. So we're going to repeat our steps. Step 1 is isolate absolute value. So we're going to subtract 1 to both sides. So x plus 7 is equal to 8. We're going to make our two equations. So, one with positive, one with negative. Step 3 is to solve. minus 7, those will cancel. X equal to 1, minus 7, minus 7, those will cancel. X is equal to negative 15. And the step 4 is to check. So we have 1 plus x plus 7 absolute value is equal to 9. It's going to be 1 plus the absolute value of, oops, I forgot to substitute my 1 there. Absolute value of 8 is equal to 9. 1 plus 8, the absolute value of 8, which is just 8, is 9. And by the way, absolute value just makes a negative a positive. No, and a positive just stays a positive. That's the whole point of absolute value. Everything is positive. If I did not mention that before. 1 plus the absolute value of negative 15 plus 7 is equal to 9. So 1 plus the absolute value of negative 8 is equal to 9. The absolute value of 8 and negative 8 is positive 8 because it's an absolute value. So 1 plus 8 is equal to 9. 9 is equal to 9. There you go, smiley face, check mark, heart, whatever helps you remember that you did your check step. Okay, so awesome. Now we have our third example, so we're going to do our step 1, which is isolate the absolute value. So we're going to divide by 2, get the absolute value on its own. The absolute value of x minus 5 is equal to 5. Now we're going to write our two equations, step 2. One with the positive this side and one with the negative this side. So we got, and we're going to take away our absolute value, x minus 5 is equal to 5, and x minus 5 is equal to negative 5. We're going to do step 3, which is solve for x. And then we're going to do step 4, which is check. So 2 times 10 minus 5 is equal to 10. 2 times the absolute value of 5, which is just 5, is equal to 10, so 10 is equal to 10. That's correct. And then we have 2, 0 minus 5 is equal to 10. To the absolute value of negative 5, which is just a positive 5, is equal to 10. So 10 is equal to 10. Yay! Okay. Now here's some practice problems. You're just going to solve for x, and there's absolute values in here. Pause the video now to solve these out on your own, and then unpause the video for the answers. Okay, so here is the answers for these problems. I solved out the work. So the first one, the answers are x is equal to 5, x is equal to 3, in the second one is x is equal to negative 4, x is equal to negative 6, and the third one is x is equal to 5 and x is equal to 13. Once again, for the sake of space on this, I did not write out the check step, but it's very important to do the check step. Okay, so inequalities is our next topic. For inequalities, we have 2x. Let's look at our first problem. Our first step is that we're just going to kind of treat this like a normal equation, and we're just going to solve for x. So we're going to do the same thing we did with our two-step equations. So solve for x, and our first way to do this is to combine like terms. Here our like terms are 6 and 16, because neither of them have x's, so I'm going to subtract 6 to both sides so I can cancel that out. 2x is greater than 10. Now we're going to just isolate x on its own, divide by 2, and x is greater than 5. Now to check this, we will take a number that fits this description and plug it into the original equation. So x is greater than 5, so we have to choose a number that is greater than 5. So let's just choose 6. 2 times 6, where the original x was, plus 6 is greater than 16. 2 times 6 is 12, plus 6 is greater than 16. 18, because 12 plus 6 is 18, is greater than 16. Yay. Check, so our answer is x is greater than 5. Okay, just as a side step, we're also going to learn how to graph inequalities. So if this is our final answer, x is greater than 5, and we have a number line, we have to know how to graph this. I'm just going to graph 5 because that's our number. This would be 4, 3, 6, 7, and so on and so forth. We have to know how to graph this. So the way we know how to graph this is by looking at this symbol. So there's two options for dots you can have. You put your dot on the numbers across from your x. So in our case, it's going to be 5. Our dot's going to be above the 5. Open dot or closed dot. Well, if x is greater than or less than, no equal to whatsoever, it's going to be an open dot. If there is a x is greater than or x is less than, it's going to be a closed dot. So in our case, it's just, there's no equal sign, it's just greater than. So we're going to have an open dot above the 5. Now we got to determine a left arrow or a right arrow. Well, if it's x is less than left L less L, the arrow is going to go to the left. If the arrow is going to the right, it indicates that it said x was greater than or equal to. You see how greater has two R's in it? And right has an R in it? That's how you do that. So in our case, x is greater than 5. So we're going to go to the right, and that's how you graph it. Okay, so here's the rules one more time, just for you to look at and read over. Now we're going to move on to our next example. Oh, whoops, I wrote an equal to there. Let's make that, okay, let's make that. So we're going to do our step 1, which is just solve for x like a normal 2-step. So we'll subtract 12, combining our like terms. (30 minus 12 is 18. Okay, so this is what we got. Our second step is now to check. So a number that is less than or equal to 6. We can use 6 in this case because x can equal 6. So we're going to do 3 times 6 plus 12 is less than or equal to 30. So this could be 18 plus 12, 30. 30 is less than or equal to 30, which is a true statement. So there we go. Now we're going to graph it. So we have 6. I like putting two numbers on either side. So now, looking back at our rules, we had x is less than or equal to. Because there's an equal to, we're going to have a closed dot above the 6. And it's less than. And less than, L, and L indicates a left arrow. So we're going to be going to the left. That just means all these solutions will work in this equation if you plug them in for x. All these numbers to the left of 6. Okay, this example is telling you guys to be cautious with negative numbers because when you multiply or divide across a sign, it flips. And I'll show you what I mean. So we're just going to solve this out with our normal steps. So 1 is just to solve for x. 4. Those cancel, so negative 2x is less than or equal to 8. Divide by negative 2. Divide by negative 2. You see how we kind of go across the equation side when we divide by negative 2? How it goes across to both sides? That means we have to flip this sign. So x is now going to be greater than or equal to -4. So you see that more detail. Here's the do's and don'ts simplified. So on the do side, if we divide by -5 to both sides, see how the negative is being divided both sides, it goes across? That means we're going to flip the sign. But if it doesn't go across, see how we're just dividing by normal 5 here, but there just so happens to be a negative here, we don't flip the sign because it did not go across the thing. It just stayed on its one side. So there's going to be -2. There's the differences between when to flip the sign and when not to. We went across the sign, so we flip. So flip on this side and don't flip on this side. The do's and do nots. The do nots on this side would be if I flip the sign. Don't flip the sign. That is bad. So don't flip. Whoops, I meant to write don't. Do not flip because we didn't go across. Okay, so in this case we did go across, so we do flip the sign. Now we're going to move into our check step. So check. So we can use -4 because x can be equal to -4 as indicated here. So -2 times -4 minus 4. Okay, so we have a closed dot because there's an equal to in the sign. And because x is greater than, it's going to go to the right. Okay, awesome. There's our do's and do nots again. Okay, so here's some practice problems. So pause the video now to work these out on your own and unpause the video for the answers. Okay, so here are our answers. I got x is less than 6, so we have an open dot going to the left, left, L and L, to the left. We have x is greater than or equal to 7, so closed dot because there's a greater than 2, and we're going to the right because greater than has 2 r's, right has an r. And then we have x is greater than -2 because we divided by -4 on both sides. We had to flip the sign. So we have x is greater than -2, and it's going to be open dot and to the right. Thanks for watching, guys. I hope you guys learned something new today. This is Maysie Calzone from Maysie's Algebra Initiative, signing off.